Now we are done with the prompt, we are done with the retriever, we are also done with the user query. So the next thing which we need is our LLM model. So to use the large language model, we have to first download it. And in our case, we are using WizardCoder model. So let's first go to Hugging Face. So search Hugging Face, click on the first result. Here you can search the block WizardCoder hyphen Python. We are using this one, the block WizardCoder Python 7 billion version 1.0. So if you want to download this model, you can go to this files, and here you can see all the WizardCoder Python model with the 7 billion parameters. So let's first read about this model little bit. So let's go little below. So here in this 7b represents 7 billion parameter, meaning this WizardCoder Python model is trained on 7 billion parameter. There are two other models. One is 13 billion parameter and the other one is 34 billion parameter, meaning they are trained on 13 billion parameter and 34 billion parameter. And even in this 7 billion parameter model, we have different model with the different bits. So what I mean here is, so the first model is Q2K, then Q3KS, then Q3KM, and further on we have till Q8. So Q2 represent, meaning this model uses 2 bits to calculate the answer. And if we use Q4, it uses 4 bit to calculate our answer. And for Q8, it uses 8 bit to calculate our answer. Higher the bit, more accurate the result, but it will require more computational power. So, and also the size of the model will be larger if we use more bit size of model. And we also have provided the max RAM required to run a particular model. For Q2, we required 5.3. So you can check according to your system which model you can use. So, so we will be using this 7 billion Python WizardCoder model with the Q4, meaning it will use 4 bits to calculate the answer. So let's go to the files. Let's first download this. We are downloading this 7 billion WizardCoder Python model with the Q4, meaning it will use 4 bit to calculate the answer. So let's click on this download icon to download it. It will start downloading your model. So after your download is complete, create a new folder here. Let's name it as a models. Move that WizardCoder to this models folder. Now to use this WizardCoder model with our RAG application, we have to use LlamaCPP. So go back to this website, click on this model card, go little below. So there are two ways to use this WizardCoder model. So the first way is to use with LangChain and LlamaCPP Python, and the second way is used to with LangChain and C transformer. So we are going to use this WizardCoder model with LangChain and LlamaCPP Python. So click on this first one. So this page is about how to use LLM models with LlamaCPP and LangChain. So let's first install this using pip. So pip install llama cpp python. Enter. So it will install llama cpp python for you. Let's wait for the installation. So if you also getting this error while installing LlamaCPP Python, which is failed to build installable wheels for some PyProject.yml based project. So to solve this error, let's first read the error. Here it's saying it could not find Git, and because of that it was not able to install LlamaCPP Python. So to solve this error we have to first install Git. So let's go to your browser, search Git, go to their official website. If you are a Windows user, click on this Windows. If your system is 32-bit, then click on this first link, otherwise click on the second one. It will install Git for you. So after installation is complete, click on this file, read the license if you want, and then click on next. Set the path for your Git, click on next, click next, next, click on next, again click on next, 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 and install. It will install Git for you. After Git successfully installed, click on finish. Then to check if Git is successfully installed in your system or not, open your terminal, type git version. It will give us the Git version if it is successfully installed. So as you can see, Git is successfully installed in our system. So let's close this. Now let's try to install LlamaCPP Python again. As we can see, after installing Git, we were successfully able to install LlamaCPP Python. But make sure you have restarted your system before installing LlamaCPP Python. So let's go back to our app.py. Here we will use the LlamaCPP Python to work with our LLM. So let's go back to LlamaCPP. Here to use the LlamaCPP, we have to first import LlamaCPP from LangchainCommunity.llms. So copy this. Now let's create a function def load LLM. It will return us the interface for LLM. So now let's define a variable LLM. Now we will use llama cpp. Inside this we have to first provide the path for our LLM model. So if you go to the official documentation, here you can see that we have to first provide the path for our LLM. So go back to your app.py, type model path, and here pass the path for your WizardCoder model. Now the second parameter which we will use for our LLM is this callback manager, which support token wise streaming. So let's copy this. Make sure you add comma. Now we also have to import this. So to import this, We can import them from LangChain core.callbacks. So let's copy this one. Now we also have to install this LangChain core library. So pip install LangChain core. It will install the LangChain core for you. Now to use this callback manager, we also have to define one additional parameter, which is verbose, and we will assign the value to true. So the next parameter is f16 underscore kv, and we will assign it value to true. So what this parameter say? So f16 means here 16-bit float value and kv means key value. So this f16 underscore kv says it will use 16-bit float key value caching, which will reduce the memory uses and it will improve the performance. And the next parameter is an GPU layers, and we will assign it value to -1. So what this parameter does, it will load the model layers onto the GPU. So here -1 represent that it will load all the model layers onto the GPU. If we use value to 0, then it will load all the model layers to CPU. So we are using GPU in our case, so -1. Let's set the next parameter, which is nctx, and let's assign its value to 16000. So what will this parameter does? It will set the context length. So a higher the value will allow the model to remember more, but it will increase the RAM uses. And the next parameter is max tokens. Let's assign its value to 500. So what this parameter do is it limits the maximum number of tokens generated in single response. And the next parameter is nbatch. Let's assign its value to 8192. What this parameter do, it defines the number of tokens processed per batch. So higher the value of this, then it will increase the speed, but it will require more memory. So the next parameter is n threads. Let's assign its value to 40. So it specify the number of CPU threads which we want for computation. So it will increase the speed. And the next parameter is streaming. Let's assign its value to true. So what this parameter do, it enables streaming output, meaning tokens will be generated and returned incrementally. So this parameter is usually used for real-time application. The next parameter which we will be using is temperature. So temperature, let's assign its value to 0.01. So what this parameter do, it control randomness in the output. So a lower value makes responses more focused towards the query, and a higher value increases the randomness. The next parameter is top p. Let's assign its value to 0.95. It is a nucleus sampling parameter, meaning it will tell the model to only consider the top 95% most probable tokens. So by doing that, it reduces less relevant tokens while allowing some diversity. So the next parameter which we are going to use is top k. Let's assign its value to 40. So what does this parameter do? It limits the token selection. So here we are using 40, so it will limit the token selection to top 40 most probable tokens. Now let's move towards the next parameter, which is repeat penalty. So let's assign its value to 1.2. So what this parameter do? It penalize repeated tokens to reduce repetition. So if the value is greater than 1, meaning it discourages the repetition, meaning it will penalize the repetition, so it will reduce the repetitive words. But if the value is less than 1, then it will encourage to repeat the repetitive words. Now let's move towards the next parameter and our final parameter, which is the stop parameter. So here we will assign it the value to triple hash. So what it will do, it will tell model to stop generating tokens if it encounter this sequence of character. So it is very useful for structured outputs. Now we can just return our LLM.